Hey guys, it's Miss Dixon. So in this video, we are going to talk about one of the different things that can affect density. So before watching this video, you should have looked at the definition of density and then at the two parts that make up density, mass and volume. Okay, so in the next lesson series, Mr. Schmidt is going to go over how to calculate density. So you're going to talk about numbers and some calculations and taking some measurements. Right now, we are just focused on the concept of density. So understanding what density is and why different things have different densities. So the first thing that we are going to look at is different materials. Okay, so when we think about materials in chemistry, a lot of times we're thinking about one type of element or one type of molecule that is repeated over and over and over again to make up something. So for example, on this sheet that you see here, you have three different materials. You have aluminum, copper, and iron. So each of these three things are elements. They're each found on the periodic table. But we also know that you can have large quantities of these things. So you can have an entire roll of aluminum foil. You can also have lots of things that are made out of aluminum, like aluminum cans. Same thing goes for copper, okay, and for iron. When you have something that's really big that is made up of these elements, they're just made up of over and over and over and over and over again, the same atom repeated, okay? So when we're talking about density, and we're talking about different substances that are all made up of the same atom, they're all pure substances, the density of those things is it's a quality of the thing. So for example, aluminum will always have a density of 2.7. Now, when you deal with calculations next week, you can deal with units and this 2.7 and what it actually means. The only reason we have numbers right now is so that we're able to compare them. Okay? So for aluminum, it doesn't matter if you're dealing with a really, really, really thin sheet of aluminum, or you're dealing with a ball of aluminum, or you're dealing with a can made out of aluminum. Aluminum always has a density of 2.7. Copper has a much higher density. It has a density of 8.96. So again, whether you're dealing with something really small that's made out of copper or something really big that's made out of copper, the shape, whatever, it doesn't matter. It'll have a density of 8.96. The same thing with iron, 7.87. Okay? So what we're going to look at is what does that look like to have these different densities? We're going to deal with something called a particle diagram. You've probably done them already. Usually you do them in middle school science, and you've definitely done them in IPS. What a particle diagram does is it zooms in really small to look at the actual particles, so either the atoms or the molecules that make up something that we're talking about. So when we're talking about these three substances and we're talking about densities, okay, we want to know what do the particles look like that make these three things different. So if we look at aluminum, okay, it's a solid, right? Well, we're assuming we're talking about solid aluminum. So we're going to take these particles and we're going to put them close together. So if this is our sample of aluminum, we can see that each of these particles would actually be an aluminum atom, okay? So maybe, you know what's in an atom. You've talked about it before in IPS, protons, neutrons, electrons, that kind of stuff. These are each individual atoms. We've just represented them with circles so that we can zoom in and see what this would look like at the atomic level. So if this has a density of 2.7, okay, this has a density that is almost 3 times that, okay? That has to mean that these particles for copper, there are more of them. They're heavier, they're closer together, they're more dense. So if we look at copper then, we want more particles in the same amount of space. So when I'm thinking about density, sometimes it's easier to think about it in terms of people. If you can think about a really, really densely populated area, okay? Now that we're dealing with COVID, it's probably a little bit easier to think about because it's all of the places that we haven't been able to go. So imagine standing in the student section of a football game, or being at a concert where people are all packed really, really tightly together, okay? If you take those people and you spread them out, maybe over the entire football field instead of just in the student section, you've made that population less dense. So right here, we are dealing with particles that are a little bit more spread out. There are fewer of them in this area. And now here, we're dealing with particles that are much closer. They are much less spread out. They are much more tightly packed in the same amount of space. That's what makes this copper much more dense than this aluminum. We can look at our third example of iron. So if we look at our iron, it's less dense than copper, but more dense than aluminum. So when we draw this one, we need particles that are closer together than this, but less close together than this. So probably we need particles that are a little smaller than this, but a little bit bigger than this. Okay. So if we look at this, and you were to count up the number of particles, you would find that this has the most particles in this amount of space. Then this one, then this one. Or these particles are the closest together. These are a little bit farther apart. These are the farthest apart. Notice that all of the particles are still touching though, because we're dealing with solids. In the next video, we're going to deal with different states of matter, and then you'll see how these particle diagrams will change. Okay? I want you to practice a little bit. Here is a problem. You can copy this into your notebook. You've got two substances. You have lead and you have tin. I want you to think about these numbers and do a drawing of these two substances based on their densities. So go ahead and pause this video right now. Take the time to draw this out in your notebook. It should only take you a couple of seconds. And then when you're ready to keep going, play the video again and check to see if you got your answer correct. Okay, so when we're looking at this problem, we know that lead is much more dense than tin, which means that we're going to need to fit a lot more particles in this space than we are in this space. So when we draw lead, we want these particles to be very, very, very close together. Notice in order to make them so close together, I have to make them a little smaller, which tends to be how these work. Okay, and then if I look at tin, lower density, more space in between the molecules. All right. Notice not a ton of difference because they are both solids, but fewer molecules here, slightly more spread apart, more molecules here, much closer together.